Dear students, today we will talk about gums and resins. Gums and resins are natural substances derived from plants, typically exuded from various plant tissues. They have been utilized by humans for thousands of years for various purposes, including medicinal, culinary, industrial, and cultural applications. Detailed introduction to both. Starting with gums. True gums are formed from the disintegration of internal plant tissues, mostly from the decomposition of a cellulose in a process called gummosis. Gums contain high amounts of sugar and are closely allied to the pectins. They are colloidal and soluble in water, either dissolving entirely or swelling, but they are insoluble in alcohol and ether. They exude naturally from the stems or in response to wounding of the plant. Commercial gums arrive in the market in the form of dried exudations. Gums are especially common in plants of dry regions. They are used primarily as adhesives and are also used in printing and finishing textiles, as a sizing for paper in the paint and candy industries, and as drugs. Three important commercial plant gums are gum arabic, gum tragacanth, and caraya gum. Here we will discuss about all the three types of gums. Starting with gum arabic, a dried gummy exudate obtained from the Acacia senegal and related acacias. These are small native trees of arid northern Africa and are extensively cultivated in the Sudan. The trees are tapped between February and May when the fruits are ripe. Gum arabic is slowly and completely soluble in cold water and has a high degree of adhesiveness and viscosity. Most has been used in textile, mucilage, paste, polish, and confectionery industries and as a glaze in painting. In medicine, it has been used as an emulsifying agent and as a demulcent. Gum tragacanth. This is formed by the transformation of the pith and medullary ray cells into a mucilaginous substance that exudes naturally or after the bark has been punctured. It comes from Astrangulus gummifer and other species of that genus. They are thorny shrubs of the arid regions of Western Asia and Southeastern Europe. The gum is allowed to dry on the bark before it is collected. It reaches the market in one of the three forms: tears, which are the dried natural exudate; vermiform gum, which consists of narrow twisted coils or strings; and flakes, which are ribbon-like pieces. Most of the commercial supply originates in Iran and Turkey. Gum tragacanth has been used in calico painting and for other industrial purposes. It is one of the oldest drugs and was known since 300 BC. In modern medicine, it has served as an adhesive agent for pills and torches and for the suspension of insoluble powders. So, discussing the last type of gum, that is caraya gum. Caraya gum has been used as a substitute for gum tragacanth and several million pounds were imported annually from India by the mid of the 1900s. It is used in the textile, cosmetic, cigar, past and ice cream industries. It is obtained from Sterculia urens, a large tree in the central India. Discussing about the uses and applications of the gums, gums are widely used in food industries. They are used as stabilizers, thickeners, emulsifiers in various food products like sauces, dressings, ice creams and bakery items. They are used in pharmaceutical industry as binders, disintegrants and controlled release agents in tablets and capsules. They are also used in cosmetic industry as thickening agents, stabilizers and emulsifiers in creams, lotions and makeup products. They have also their applications in industrial as adhesives, coatings, textile printing and more. Discussing about the resins. Resins are formed as oxidation products of various essential oils and are very complex and varied in chemical composition. The resin is usually secreted in definite cavities or passages. It frequently oozes out through the bark and hardens on exposure to air. Tapping is usually necessary in order to obtain a sufficient amount to be of commercial value. Commercial resins are also frequently collected from fossil material. Resinous substances may occur alone or in combination with essential oils or gums. Resins, unlike gums, are insoluble in water, but they dissolve in ether, alcohol, and other solvents. Resin production is widespread in nature, but only a few families are of commercial importance. These include Anacardiaceae, Burseraceae, Diptocarpaceae, Guttiferae, Hemelidaceae, Leguminosae, Liliaceae, Pinaceae, Styracaceae, and Umbelliferae. The exact botanical origin of a resin is often hard to trace, especially in the case of fossil and semi-fossil types. Resins probably serve the plant by preventing decay, which is due to their high antiseptic qualities. They may also lower the amount of water loss from the plant tissues. Resins have certain characteristics that render them important to industry. Their ability to harden gradually as the oil that they contain evaporates makes possible commercial varnishes. The resins are dissolved in solvents and surfaces are painted with the mixture. As the solvents and oils evaporate, a thin waterproof layer of resin remains. Resinous substances have been utilized for waterproof coatings and also for decorative coatings for millennia. Ancient Egyptians varnished their mummy cases, and the utilization of lacquer in the arts has been practiced in China and Japan for centuries. The Greeks and Romans were familiar with many of the same resinous materials that are used today. Another property of resins that is of industrial importance is their ability to dissolve in alkalis to form soap. Resins are also used in medicine for sizing paper, as a stiffening material for mats, in the preparation of sealing wax, incenses and perfumes, and for many other purposes as well. It is difficult to classify resins because the same term is often used for very diverse materials. In commerce, resins are often referred to as gums, while such terms as varnish resins, hard resins, spirit varnishes, balsams, gum resins, damar resins, soft resins, and many others are used quite indiscriminately. The chemical differences between the various groups are much more definite. In this lecture, we will be discussing three main types of the resins, that are hard resins, oleoresins, and gum resins. Hard resins. These contain only a little, if any, essential oil. They are usually solid, quite transparent, brittle substances with no particular odor or taste. They are readily fusible and burn in air with a smoky flame. They are non-volatile and very poor conductors of electricity. They become negatively charged with friction. The hard resins constitute the best sources of varnishes due to their low oil content and the readiness with which they dissolve in alcohol. The most important commercial resins, such as the copals and the dammers, belong to this group. Hard resins are also used in paints, inks, plastics, sizing, adhesives, fireworks, and other products. Copals. Copals comprise a considerable group of resins of recent semi-fossil and fossil origin that are found in many tropical and subtropical areas of the world. The world copal is of Mexican origin. Many of the harder copals are called anemones, especially in northern Europe. The copals are of insignificant quantities of oil. They yield a hard elastic varnish, which has been widely used for outdoor work. Dammers. The word is of Malayan origin and is used by the natives to indicate a torch made of decayed wood and bark, mixed with oil and powdered resin, wrapped in leaves and bound with strips of rattan. At one time, it didn't refer to any specific tree or resin. However, the word came to be a collective term for a great variety of hard resins of different origin and included even kauri and Manila copal. A few resins from the species of Burseraceae are also included. This distinction should be maintained, for the true dammers are very different chemically from the various coniferous resins. Unlike Manila copal, dammer is insoluble in chloral hydrate but completely soluble in alcohol and turpentine. Dammers were used principally in separate varnishes and the manufacture of nitrocellulose lacquers. Dammer varnishes adhere better than Manila copal varnishes, but are softer and less durable. They are particularly well adapted for varnishing paper because of their luster and light color. They have also been used for indoor work and in histology. Amber. Amber is a fossil resin found mainly along the shores of the Baltic Sea and to a lesser extent in Mexico, Central America, and Caribbean islands. The principal source of Baltic amber was now the extinct pine, Pinus succinifera, that flourished on the shores of a former sea in the Eocene. Amber is very hard and brittle. It occurs in several forms, the most important which is succinite. Some of these forms are transparent and others are almost opaque. The color varies from yellow to brown and even black. Amber assumes a high polish and becomes negatively charged when rubbed. It also gives off a characteristic aromatic odor. This substance has been known for thousands of years. The Swiss lake dwellers were familiar with it and was highly prized by the Greeks and Romans. It has always been used for beads and other ornamental purposes and is often carved. The chief use of amber is for the mouthpieces of pipes and cigarette and cigar holders. The darker grades yield a valuable varnish, but this is too costly for general use. Amber is also used to increase the elasticity of rayon fibers and as a source of an essential oil. It is of scientific interest that there are often found embedded in amber the remains of plants, insects, and other objects that existed at the time the fresh resin was exuded from the pine trees. Lacquer. Lacquer is a natural varnish that exudes from various trees in Asia, and great quantities of it are used in the Orient for ornamental purposes. The principal source is the lacquer tree, that is Rhus verniciflua, native to China but cultivated in Japan. The trees are systematically tapped. The exudate is a milky liquid which darkens and thickens rapidly on exposure to air. However, it can remain unchanged for long periods by storage in closed containers. It is filtered before use. When applied as a varnish, the thin film rapidly hardens in a moist atmosphere, in part due to oxidation. Coming to the next type of the resins, that is shellac. True shellac is not a direct plant product but deserves a discussion here. It is made from sticklac, that is a resinous substance secreted on the twigs of many trees by an insect, Tacardia laca. The lac insect derives its food from the sap of the trees and secretes the resin as a kind of cocoon for its own production and that of its offsprings. Although there are about 40 species that may serve as hosts for the insect, but only 7 are of importance. These are often cultivated. They include Butea monosperma, Ziziphus xylopyrus, Ficus religiosa, Acacia nilotica, Cajanus cajan, and Ziziphus jujuba. Butea monosperma was used as a host as early as 250 AD. At first, a valuable red dye which was obtained from the insect was the only sought after product. However, since 1590 AD, the resinous excretions have been more important. Native workers prepare most of the shellac of industry. India furnished over 97% of the total output by the mid-1950s, the rest being from Burma, Thailand, and Vietnam. The crude sticklac is removed from the twigs and soaked in water to extract the red dye. It's then dried and powdered to a granular consistency. This seedlac is melted and thin sheets of it are hardened. These are broken into the semi-transparent, brittle, orange-red flakes which make up shellac. If the melted seedlac is poured out into droplets, it hardens into the thick round pieces known as buttonlac. Shellac is often bleached. At one time, shellac had many industrial uses, but synthetic substitutes made from petroleum have greatly competed with it. True shellac can be molded readily and was the most satisfactory material for the manufacture of phonograph records. It is an insulator of the highest grade and was once extensively used in the electrical industry. It was a principal separate varnish resin yielding a tough film with a smooth finish which is also capable of a high polish. Shellac varnishes cannot be used out of doors because they are not water resistant. Shellac was also used in making sealing wax, drawing inks, some watercolors and nitrocellulose lacquers, for sizing papers, for stiffening felt hats, and in India for many ornamental purposes. Acaroid resins. These are grass tree resins obtained from Australian trees belonging to the genus Xanthoria. These plants are among the few monocotyledons other than palms which have an arboreal habit. They consist of a short woody stem composed of the old leaf bases surmounted by a tuft of long rush-like leaves. The resin collects around the bases of the old leaves and is removed by beating the stem. The yellow acaroid resins reach the market in the form of elongated or round reddish brown pieces. They are obtained chiefly from Xanthoria hastilis, red acaroid resins from Xanthoria tetina, Xanthoria australis, and related species are much more common. They consist of uneven pieces of a brownish color. The acaroid resins are used in the manufacture of sealing walls, gold size and separate varnishes for use in coating metals, as a substitute for resin in paper sizing and inks, as a mahogany stain, as a source of picric acid and in medicines. Another type of resins here is sandark. This is a soft, pale yellow resin obtained mainly from Tetracalinus articulata, a small tree in northern Africa. Australian species of Calatrus are also a source of sandark. The resin is formed between the inner and outer layers of the bark, and it is excreted in the form of small tears, which quickly become opaque. Sandark yields a hard, white, rather brittle separate varnish that is especially useful for coating labels, cardboards, leather, and metals. It was once used in medicine and was well known to previous civilizations. Another type here is mastic. This is a very old resin that was known at least as far back as 400 BC. The most useful variety is Chios mastic, derived from Pistacia lenticus, a small tree from the Mediterranean area. Although the resin exudes naturally, removing strips of bark enhances the flow. Some of the resin adheres to the trunk in the form of long, ovoid, pale yellow, brittle tears. while the remainder falls to the ground. Bombay mastic, which consists of large irregular pieces of a dull milky color, is from Pistachia cabalica. Mastic yields a pale varnish used for coating metals and pictures, both oils and watercolors. It's also used in lithographic work, in perfumery, in medicine, and as a cement for dental work. It's one of the most expensive and high-grade resins. Another type is dragon's blood. Included here are various deep red materials of a resinous nature. Sumatra dragon's blood is from Daemonoropus draco, a climbing rattan palm of Eastern Asia. The dark reddish brown resin forms small granules on scaly fruits. It's used mainly in the manufacture of red spirit varnishes for metals and in making zinc line engravings. During the 18th century, Italian violin makers used dragon's blood in their varnishes. Socotra dragon's blood is a resin that exudes from the stem of Dracaena cinnamomum of Western Asia. It has been also used for varnishes, dyes, and stains. Dragon's blood is sometimes secured from tropical American species of Dracaena and other Asiatic species of Daemonoropus. Another type of resins here is quinose. Gum quinose are produced by several plant species. Malabar quino is derived from the dried juice of Pterocarpus marsupium, a large tree in India. Trees are tapped and the juice is boiled down. It reaches the market in the form of small brownish red brittle pieces. West African quino is a red resin from Pistacia erinaceus. Bengal quino is from Butea monosperma. Some Australian species of eucalyptus are also sources of gum quino, but mainly Eucalyptus camelodulensis. The quino is secreted in the cavities between the wood and the bark and oozes out after having incisions. In the air, the resin hardens into a solid reddish mass. Several tropical American trees, mainly Dipteryx odorata and Cocoloba uvifera, also yield quinose. Quinose have found their main use in medicine for throat disorders and are sometimes used in tanning. Talking about the last type of resins, it is oleoresins. A considerable amount of essential oils are contained in oleoresins, in addition to the resinous materials. Thus, they are often liquid in nature. They have a distinct aroma and flavor. Among the oleoresins, we find the turpentines, balsams, and elemis. There is only a very slight distinction between these groups and often a confusion of names. Resins have a wide range of uses across various industries due to their versatile properties. Lastly, talking about the applications of the resins. Resins find their applications in adhesives. Resins are often used as the base material in adhesives and glues. They provide bonding, strength, and durability in various materials such as wood, plastics, and metals. They are used as coatings. Resins are key component in coatings for protection and decoration of surfaces. They are used in paints, varnishes, and sealants for surfaces, ranging from wood and metal to concrete and plastics. They are used in composites. Resins are used as matrix materials in composite materials such as fiberglass and carbon fiber composites. These composites are lightweight and strong, making them an ideal for application in aerospace, automotive, marine, and construction industries. Resins are also used in insulation. They are used in the production of insulation materials for building and appliances. They provide thermal and electrical insulation properties, contributing to energy efficiency and safety. They are used in casting and molding. Resins are used in casting and molding processes to create intricate shapes and parts. They are commonly used in industries such as automotive, electronics, and jewelry for manufacturing components. Used in 3D printing. Resins are used as printing material in stereolithography and digital light processing 3D printing technologies. They allow for the creation of high-resolution, detailed objects in various industries, including prototyping, medical, and engineering. They are used in water treatment. Certain resins are used in water treatment processes for ion exchange, filtration, and purification. They help remove impurities and contaminants from water, making it safe for drinking and industrial use. They are also used in electronics. Resins are used in the production of electronic components and circuit boards. They provide insulation, protection from environmental factors, and adhesion properties crucial for the performance and longevity of electronic devices. They are also used in textiles. Resins are used in textile finishing processes to impart properties such as stiffness, wrinkle resistance, and water repellency to fabrics. They also find their usage in arts and crafts. Resins are popular material in art and craft projects for their ability to create clear, glossy coatings and encapsulations. They are used in jewelry making, sculpture, and mixed media art. So dear students, thank you all for joining today's lecture. I hope you find it informative and engaging. Thanks.